The first part of section 5.4 on factoring. Factoring the polynomial completely. Remember to always take out a common factor first. This first one, if you look at 3, 30, and 75, I know that I can take a 3 out of those, so I'm going to put that in front. Notice also they all have x's. Always take out the smallest exponent of the x's. So it's going to be x to the first that we're going to take out. Then here for this term, I would have x squared left. 3 goes into 30 10 times, so I'd put plus 10. I took out 1x, so I'd have 1 left over. So I need an x here. Plus 3 goes into 75 25 times. I took out the x already, so that would be the first part of factoring. That's taking out any common monomials first. Now I'm going to drop this 3x down. This can be double bubbled, okay, which also means factoring. We break up x squared into x and x, and then factors of 25 that are going to add up to 10 would be plus 5, plus 5. Remember to check your signs. Positive times a positive gives you a positive 25, and they add up to be 10. That is going to be the final factored form for that problem. Moving over to the next one, 5 and 80, I can take out a 5. The smallest exponent on the g's that I can take out is g cubed. That's going to leave me with g squared for the first term, minus 5 goes into 80 16 times, and I took out the g cubed, so that would be it for that one. 5g cubed falls down, and then I'm going to double bubble that. I'm going to have g and g. Factors of 16 that will give me no g's in the middle would be plus 4, minus 4. And the signs work out because positive 4 times negative 4 gives me the negative 16. Now we have a couple of formulas. We have sum of cubes and difference of cubes. The first thing I need to do is look at this. Are there any common factors that I can take out? There are not for this problem. So the next thing I need to do is I need to figure out what is my A and what's my B. A is going to be the cubed root of this term. So you have to think about what is the cubed root of 27. In other words, what number cubed gives us 27? Well, that would be 3. And then if I take the cubed root of x cubed, that would just be x. So my first term, A, would be 3x. And then I need to figure out what B is. So I'm going to take the cubed root of 125. That is 5, because 5 times 5 times 5 is 125. Now, since there's a plus sign in here, I'm going to use this formula over here, and I just plug in my A and B. Since it's A plus B, it'll be 3x plus 5 times A squared. Okay, so if I squared this whole thing, 3 squared is 9, x squared is x squared. And then it's going to be a minus sign. Notice there's a minus in there. And then A times B, 3x times 5 is 15x. And then I'd have plus B squared, that's going to be 25. And that's going to be my final answer for factoring. Now, this right here looks like something that you could double bubble. Once you've done a sum or difference of cubes formula, you will not be able to factor either of these last two, okay? And that's only if you've done the sum or difference of cubes formulas, okay? Next one. Again, look for a common factor. I can take out a 2. I'm going to go even further. I'm going to take out the negative 2. Okay, so that'll make this first term positive. It's always a little easier if you make the first term positive. I can also take out a d squared. Both terms have a d. Take out the smaller exponent of the 2. That's going to leave me with d cubed for the first term. Since I took out a negative, I have to change the sign to minus. 2 goes into 250 125 times, and I took out the d squared. Now the negative 2d squared, that's going to fall down. That's going to stay there. Okay? But I do need to figure out what's a and b for these terms. Okay? A in this problem would be d. B in this problem, the cubed root of 125, would again be 5. The difference with this problem is that we have a minus sign in between here. So I need to use this formula for my difference of cubes for what's in the parentheses here. Okay, so I've got a minus b first, so it's going to be d minus 5. And then it's going to be a squared, so that would be d squared. Notice this time the sign is a plus. And then you take a times b, d times 5 would be 5d. And again, another plus sign in the formula, so plus, and then b squared is going to be 25. Okay, so this would be my factored form for this second problem. Grouping is pretty cool. Notice there's 4 terms in these problems. Okay, there's 4 terms. Here's what we're going to do. We're going to split this up. We're going to take the first 2 terms, and I'm going to take out the greatest common factor. 27 and 45. I know that 9 goes into both of those. I can also take out a t squared for those first 2 terms. So now what's left here? That would be 3t. And then here it'd be plus 5. I already took out the t squared. Okay, now I'm going to look at the second 2 terms. What can I take out of those? Well, I really can't take out any common factors, so it's going to be a 1. Always look at this first sign. I'm going to take out a negative, since this sign is negative, and I'm going to go ahead and take out a 1. Typically we don't write the 1, but I'm going to for the sake of this problem. So now what do I have left here? That's going to be 3t. Since I took out a negative, I have to change this sign to a plus, and then 1 goes into 5 times. Now notice in this problem that what you have in parentheses is both the same. So what you're going to do is you're going to think of both of these multiplications, and we're going to factor something out. And we're going to factor out the 3t plus 5. And the cool thing is you're going to write down what's left. Here in this first set of multiplication, 9t squared is left, so I bring that down. And then in this second multiplication, negative 1 is left over, so I bring that down. And then the last step is to see if you can factor any further. Always factor as much as you possibly can. I'm going to drop down the 3t plus 5. This can be double bubbled. Okay? Square root of 9t squared. This is a perfect square, so I'm going to go 3t, and then 1 is a perfect square, so I'm going to break that up into 1 and 1. And since there's a negative in the middle, it's going to be plus, minus. And that's going to give me 0t in the middle because outside would be negative 3t, inside would be positive 3t. So that would be the final factorization for that problem. There's nothing else that I can factor out of any of those sets of parentheses. Moving over to this problem, again, split this up into 2. Take these first 2. I'm going to take out an x squared. And that leaves me with x plus 7. Now we look at the second 2 terms, well, the last 2 terms, and I can take out, again, I'm going to take out a negative. 9 and 63, I can take out a 9. That leaves me with x. Remember, we took out a negative, so I changed the sign to plus. 9 goes into 63 7 times. Okay? And really, you know if you've done the grouping correctly so far if what's in parentheses is the same, okay? Because I want to be able to factor that out. So I'm going to bring down the x plus 7. I'm basically factoring that out of this multiplication and this multiplication. And then what's left? Here's x squared. And over here would be minus 9. And again, this can be double bubbled, so I'm going to drop down the x plus 7. And then we're going to break this up into x and x. Square root of 9 is 3. So I go 3 and 3. And then we have a plus minus in the middle to give me nothing in the middle here for that middle term. Now we're going to look at some more factoring. This is factoring that we've kind of done before. Always remember to look for the common factor first. I can take out a 10. And then I'm left with x to the 4th minus 1, okay? Even when you take out the 10, you have to be able to put something in here, because if I were to multiply this back out using distributive, I've got to have this minus 10 out here. So if you take out whatever is here, you need to replace it with a 1 in the set of parentheses. 10 drops down. Now I'm going to continue to factor. X to the 4th, I can split up into x squared and x squared. Now I'm going to break up the 1. That's going to be plus and minus 1. Okay. I'm going to continue, bring down the 10. X squared plus 1 cannot be factored any further. Those are both perfect squares. However, there's a plus sign in between them. So there's no way that my signs are going to work out to double bubble this set of parentheses. But x squared minus 1, we can break up into x plus 1, x minus 1. Okay? The big thing with these last problems is making sure that you factor as far as you possibly can. Okay? Moving over to this last one, I can take out a 3. Notice all the terms have an m, so I can take out an m, and I'm going to take out m squared because the squared is the smallest exponent. Now what am I left with? In the first term, I'm left with m to the 10th, plus 3 goes into 54 18 times, and I'm left with m to the 5th, and then I have plus 3 goes into 51 17 times. And I took out the m squared, so that would be the end of that part of the factoring. We're going to drop 3m squared down. Now this is much like factoring when we had m squared, except now I have to break up m to the 10th. Still works the same. I'm going to split it in half, so it'll be m to the 5th, m to the 5th. That kind of deals with our properties of exponents. If I multiplied those out, same base, we'd add the exponents. Okay, so that gets us back to this m to the 10th. Now we need to think about factors of 17 that add up to 18. That's going to be 17 and 1. So I'm going to put 17 and 1 here. Since they have to add up to positive 18, they're both going to be plus. And then two positives make a positive 17 at the end. Okay, now look at your sets of parentheses. This cannot be factored any further. This cannot be factored any further. That's going to conclude section 5.4, part 1.